Okay, hello and welcome to a video where I'm going to go through the mock solutions. I've actually just started this video, but I messed it all up after about 2 minutes, so let me try again. I thought it was quite a tough paper, this one. I don't think it's very easy, but that said, it is something that we can do. So let's just get straight into it. A rocket is launched vertically up from the ground. Rest first, so I'm going to take it going from rest. And this is velocity and this is time. We know the acceleration initially is 5. Well, remember, acceleration is gradient, yeah? And it travels up to t seconds with an acceleration of 5, and then it travels for a further 21 seconds at constant velocity, which is why this line is going to be fat here. So let's call this value v. Let's call this t plus 21. And remember, that's t plus 21, and this gap here is 21 seconds. Yeah, that's the gap. Don't get those muddled up. Either that's t plus, that's got to be t plus 21, but its gap is 21. And what do we know here? Well, we can actually find like a connection between v and t, because this 5 is rise v over run t. So straight away I know 5t equals v. By the way, I've already got these first 2 marks now with that diagram. That is plenty for the diagram. But I like to work out as much as I can when I see it. And so when I think, well, I haven't used that 5 yet, that is the gradient. So you can do it like that. Alternatively, you could just use v equals u plus at. And as u is 0 here, you're going to get v equals 5t as well. Now, that's really useful for finding the value of t, because we know that the distance underneath is 1,000. Remember, you must have it in meters. So all I've got to do now is say 1,000 equals, well, it's going to be Vt over 2. Yeah, that's just this area here. That would be V times T over 2. And then you've got plus 21V. Yeah, but we know V is 5t. So now I can substitute in V as 5t. So I'm going to get 5t squared there over 2 plus 21 times 5t. So that's 105t. And now I'm going to solve the resulting quadratic. I'm going to double everything, so I get 2000 is 5t squared plus 210t, and then I'm going to simplify it. I'm probably going to use my calculator here if I'm, like every other typical student doing this exam. It's like, right, get the calculator out, get it to solve it for me, but it does actually factorize quite nicely, and you should get from this t equals 8 or t equals minus 50. And so t equals 8. Yeah. Now, are we looking for the value of t? Yes, we are. We've got t equals 8. Hopefully, that's not too bad. The thing which people were missing was this fact here, or they were writing that as 1 kilometer, just 1. But remember, it's got to be in meters. So watch out for those 2 things. If you've got that, you end up with a quadratic which you can solve, and you're all good. Okay, so I hope that wasn't too bad, that one now. Okay, the thing is, if you didn't get that one, you were unlikely to get anything else. I think you could still do it, but often people went a little bit haywire then after that. It kind of rattled them, that question. Okay, at the point the rocket reaches 1 kilometer above the ground, a panel becomes detached from the rocket and falls to the ground. Find the velocity of the panel as it hits the ground. Now, this is a SUVAT problem. You've got an object. Let's just put an object here. Here's the ground. We're 1,000 meters up. But we've got to remember that it's traveling at a particular speed. Yeah. Now, its initial speed, u, is going to be how fast this was traveling here. Well, v is 5t, so u is going to be 40 there, and that's because we can now work out v here, because if t is 8, this is 40. Yeah, 5 times 8 is 40. So you know it's traveling with a speed of 40 meters per second up as it detaches itself. Yeah, and that's something obviously which is going to be really, really useful. So we've got u is 40 up, a is minus 9.8 down. What else have we got? We've got s is 1000, and we're trying to find v. Yeah, so this v is not the same as that v. Your v becomes u in this because it's a multi-step problem, and we've essentially got to find the velocity when it hits the ground. We've broken up the problem into 2 stages. Okay, so we're going to do v squared is u squared plus 2as. And so we're going to have 1600 here, and then we're going to have plus 2 times minus 9.8 times. Now, Note here, and I've made this little error here, I do apologize, but note we had up as positive there because u is positive. Remember, everything is about direction in these questions, yeah? It's accelerating downwards. It's also traveling downwards. It's actually doing a little arc because it will go up first and then start plummeting down. Suvat takes into account things turning around in the air, but you must have that as minus 1,000. Okay, we can now work that out and we end up with v equals 140, sorry, I've missed out a squared on the v there as well. Terrible. V squared is u squared plus 2as. Apologies for that. So you end up with v equals 146 if you're doing that to three significant figures once you've worked it all out in your calculator. For part two, it's a standard kind of stuff, really. Select a modelling assumption you have used which limits the accuracy of your answer and justify why the answer would differ, and justify why the answer would differ if this were taken into account. Yeah, so you've actually got to back up your justification. It's no good just going air resistance. Yeah, sure, it's air resistance, but what does air resistance do? Yeah, how does that change your answer? Justify why the answer would differ. Well, air resistance would prevent it falling at, it getting faster and faster and faster. In reality, things reach terminal velocity when they fall down from space to the ground. They get to a point where they don't get any faster. Our thing just keeps accelerating, accelerating, accelerating because we've ignored air resistance. So what you want to say with air resistance is that air resistance, eventually the object reaches terminal velocity. You can just put it slows down, but I'm going to use that because I quite like the idea of terminal velocity. Eventually the object reaches terminal velocity and so doesn't keep accelerating. And so acceleration isn't constant, basically. That's what happens in real life. And that's why if you ever do a skydive or anything like that, you reach a maximum speed. I think it's about, I don't know, it's about 150 miles an hour or something, but it doesn't go kilometers per hour. I might be way out on that. Look it up and see if I'm wrong. But yeah, it's interesting. You don't just keep getting faster and faster and faster, which is what we're assuming in a typical question like that. Okay, so that was quite a nasty question, I thought. It had its subtleties to it anyway. Right, let's have a look at the next one, which was a kind of lift problem, as I would describe it. They like these little lift problems, they really do. Okay, what have we got here? We've got a man traveling in a lift. The mass of the man is 50 kilograms, and the mass of the lift is 350 kilograms. Yeah, now remember, with these kinds of problems, you basically got, you can lump together, or you can look at the man individually within the lift, yeah? And you kind of have to do both in this kind of question. So you've got the mass of the man is 50 kilograms, the mass of the lift is 350 kilograms. The lift is being raised vertically by a vertical cable, which is attached to the top of the lift. The lift is moving upwards with constant acceleration. So let's make that clear. We've got an acceleration going in that direction. The cable, which is modelled as being light and extensible, has tension 6,000 newtons, yeah? Now what you want to do first is lump everything together, because then you can find the acceleration. Let's have a look at how that's going to work. So look at the whole system, yeah? The weight we've got going down, we're blobbing everything together, the man and the lift, we're treating them as one. We've got 400 G going down, we've got 6,000 going up, and so 6,000 minus 400 G equals 400 A. Yeah, all I'm doing is F equals ma here. I'm using Newton's second law. I blob together first to find the acceleration of the whole system. Then I'll be able to use that acceleration to find the force a man exerts on the floor of the lift and the force that the floor of the lift exerts on a man, because they will be balanced forces internally. Okay, that allows me to find A, and you can just work it out on a calculator, and it comes to 5.2 meters per second. What we can do now is redraw the diagram with just the man which we're interested in now, and he's going to have 50G acting down. This is the force internally within the lift, and a reaction force acting on his legs, pushing him up. Yeah, remember, when you're being raised by a lift as well, you feel heavier. Yeah, and it's the reason you feel heavier is because you've got that reaction force pushing up, and that reaction force gets stronger than if you were just standing still, not being raised. Okay, right. We've got the acceleration and we know it's 5.2 meters per second squared. And this is just a case of doing the whole thing again, the whole F equals ma again. So we just do it again. Okay, we've got r minus 50g equals 50 a. But a we know now. It's 5.2. And hence we can work out r. And if you work that out, you should get 750 newtons. I think to 3 sig fig. So that's all you need to really do here. R minus 50g is 58, and then R is 750 newtons. Now that's the magnitude that the force exerted by the man on the lift. Now, is it the man exerting the force on the floor of the lift, or the lift exerting the force on the man? Well, both will be equal and opposite. They've asked for the direction of the force that the man exerts on the floor of the lift, and that is going to be in the direction downwards, because it's the man on the floor of the lift. And that's all there is to that one. They're quite funny, those lift questions. There's a few good ones in the at the end of the Rayner book, the red mechanics book. Well worth having a look, because they like those kinds of questions. They come up occasionally, not every time, but yeah, they're quite good fun, really. Once you get used to them, they don't seem intimidating so much anymore. Okay, this one was quite friendly. I thought relatively friendly, although the direction vector often got the better of people. But let's have a look. Okay, we've got a particle that's moving with constant acceleration. So A is free fall. Yeah. Now remember, when they start giving you vectors and they say constant acceleration, this is just suvat with vectors. We also know at time t equals 0. So that sounds like right at the start. So we've got u here, minus 7, 1. Yeah. But then time t seconds, p is moving in a direction, yeah, of this vector, yeah. Now, if it's moving in a direction of that vector, it could be any scalar multiple of that vector, because it's moving parallel to that vector, so it's scalar multiples. And remember as well, direction is velocity. So what we're really being asked here is find when it's moving in that direction, find a time when it's doing that. So if you like, I've got v here. V is 2, 3 times by a constant k, because I know it's definitely in that direction. And I'm being asked to find t. Yeah, t equals question mark. Well, this is, v, u, a, and t. This is v equals u plus at. That's all I'm going to use here. I could use a capital T there. Should I use a capital T, as that's what they're using? Oh, well, I'll put it in like that in the next go. So I've got 2k, 3k equals minus 7, 1 plus 3, 4 times t. Yeah. So really what I've got here is a simultaneous equation. I've got 2k is minus 7 plus 3t. And I've got 3k is 1 plus 4t. I want to get rid of that k and find what t equals, yeah, essentially. Or I could just times the top one by 3 and the bottom one by 2. Should we do that? Doesn't really matter. 6k is minus 21 plus 9t. 6k is 2 plus 8t. And then what I could do is just equate the two. So 2 plus 8t is minus 21 plus 9t. And so I'm going to get 23 equals t. And that is the answer. T is 23. Okay, at time t equals 4, P is at the point B. Now, I don't even think you need any of the previous answer for this question. We just need to find where it is after 4 seconds. Well, we've got the same setup really here. U is minus 7, 1. Yeah. A is 3, 4. T is 4. Find S. Yeah. And did it start at the origin as well? Because you want to be careful with that. The particle is at point A. Yeah, well, that's fine, because we can treat A as the origin, because we're finding the distance from A to B. So let's find where B is, and then let's find the distance. So all I'm going to do is S equals UT plus a half a T squared. So S equals, right, minus 7, 1 times by 4 plus 1.52, I've halved the A, times by 16. And so that gives me minus 28 4 plus 1/2 16ths is 24 and 32. And so I'm going to get minus 4 and 36. So we've basically gone 4 to the left and 36 up from A to B. Yeah, that's a vector which takes us from A to B. We now just need to find the distance, so we need Pythagoras. So the distance is going to be square root of 4 squared plus 36 squared, and that comes to 36.2 meters, to 3 significant figures. Okay, I hope that one wasn't too bad either. So last one, let's have a look at the last one. This one was more difficult, although I did find people tended to do better on this, but I do think it's more difficult, without a doubt. It's much more difficult than that question anyway. Okay, right. We've got a typical police question though. That's what it is, a typical police question. As soon as I see a police question, I start putting things like 5 mg on there. Don't miss out the m's, yeah? 3 mg here. You just know you're going to be using this, yeah? Put your tensions on. Always the same with any police question. Put your reaction force on, yeah? Now, is it rough? Rough plane. So which way is it moving as well? I think they do tell you. Mu is 0.8. Let me write that down somewhere. The block is released from rest and A moves up the plane. So friction is going to be going down the plane. You know, I'm always interested, which way should I put friction? If it's traveling in that direction, friction is going to be opposing the direction of motion in that direction, and it will be a maximum as well. Don't forget to do your little angle here. Now, they told us tan alpha was 12/5. That's your opposite, and that's your adjacent. And this is a nice Pythagorean triple. So straight away you can say what sine alpha is, because sine alpha is going to be 12/13. Where am I getting that from? Well, if I was to draw a little triangle like this, with that as alpha, you've got opposite, adjacent. Use Pythagoras, you can find that as 13. Then you can see sine alpha is 12/13 and cos alpha is 5/13. Okay, beautiful. We're now in a good position once again. We're ready to start, essentially. Now, I haven't even read the question. I apologize, but I did mark this, and, you know, all these questions, they're all the same, yeah? They always get you to find tension and acceleration. Occasionally they vary it by giving you the acceleration or the tension, and you have to find the other one. But really, it's simultaneous equations to find T and to find A. Okay, right, so let's do it. Oh dear, I moved that off. That's going to mess up my diagram. Let's have a look if I can get it lined up again nicely. Oh, look, it's almost perfectly lined up. Okay, so what do we need? Well, firstly, start with the easiest one. Give yourself some confidence. Remember, the system's moving in that direction, yeah? So 5 mg must be the stronger force. So I can say 5 mg minus T is 5 ma. You must have the m's in there in the right place. Very important, that. Very important. That's worth 2 marks, by the way, yeah? For the other one, which is more difficult, we've got T minus 3 mg sine alpha minus F max. Yeah, don't try and do too much at once, because this, just writing this down, gets you another 2 marks, yeah, out of the 8. We've got 4 marks out of the 8, yeah, and fair enough, we have earned it, but, you know, it seems quite nice. Now, as R is going to be 3 mg cos alpha, and F max is mu R, so 4/5 because it's 0.8, times by 3 mg cos alpha. Let's start writing down that as 3 mg times by 5/13. Don't know if you can see that on the corner of my screen there. I'm trying to write down as much as possible before I've solved anything, because you'd be astonished to find out I've now got 6 marks, yeah, out of the 8. Have I worked out anything? No. Have I solved anything? No. Have I written down, like, you know, lots and lots of like attempts to solve? No. I haven't really done much at all, other than most of my work's been on the diagram note. A little bit of trig with a 12/5, but that's it. It's a diagram and it's a F equals ma equations, yeah? Okay, now at some point I've got to solve these. Now I'm a big fan actually of always sticking to the same kind of way, but can I just show you quickly here? The 5s are going to cancel there, so you're going to get 12 mg over 13. Yeah, try and simplify these as much as possible. So we've got the F max's value. Remember, sine alpha is 12/13, so we're going to write that down in a second. So let me just write them down all tidied up. 5 mg minus T is 5ma. That's already pretty tidy. But then we've got t. Now, sine alpha is 12/13. Times it by 3, you're going to get 36/13 mg. Yeah, I'm just getting rid of the sines and coses. Minus 12 mg/13, because that's your f max, equals 3ma. Yeah, and let's tidy it up again. So I'm just going to write down 5mg minus t is 5ma again, just to keep them all lined up, because then I get t minus 48 mg/13 equals 3ma. Now, they actually asked for t here, not a, and normally I would advise you, just add them together, solve it, then you've got a, and then you can plug it back in to find t. But it might actually be better off, we might be better off here finding, getting rid of a first, yeah? Now, what I could do is I could divide one side by 5 and the other side by 3, so in other words, 1/5 of 5mg minus t, yeah? That's ma. But also 1/3 of t minus 48 mg/13. That is also ma. And so I've kind of got rid of everything I need to. And now I just need to make t the subject here, yeah? So that's going to give me mg when I multiply out that bracket minus t/5 equals, and this is just one possible way of solving it, it's not the only way, equals t/3 minus 48 mg/39. Let's marry up the mg's. If you add an mg to that, you're going to get 39 plus 48, which is, what is that, 39 plus 48? I think it's going to be 97 mg over 39, and you can check that on a calculator. All I'm doing is adding this term here to mg, yeah, because mg is obviously 39 mg/39, and so I'm adding a 48 mg/39 and getting that, and then I've got t/3 plus t/5. I can easily simplify those a little bit. You can see the last two marks are the hardest to get, yeah? You're going to get 5t plus 3t, that's 8t/15 is 97 mg/39. And then hopefully, if I times that by 15/8, hopefully I get the answer. Let's have a look, because I haven't got my calculator outside with me. You'll just have to bear with me while I work this through. I suppose I could make that a 5 and make that a, cancel the 3 down there, making that a 13. 5 times 97, remind me what I'm heading towards here. 5 times 435 over 104. That's a little bit unfortunate, because am I going to get that? 590 to 450, 5 sevens are 35. So 450 plus 35 is 485 mg. Is that what I had there? I don't know if it was. Or was it 435? Let's do that again. 5 times 90 is 450. And then 5 times 35. So it's almost like I've gone wrong slightly up here. Where did I go wrong? Where did I go wrong? And this sometimes happens, it's part of maths, it sometimes happens at the end. What I'm kind of happy about is that 8 times 13 is 80 plus 24. That is 104. So it's almost like the 97 in the problem. Let's do a little bit of bug hunting here. This is a classic thing that you have to do at the end sometimes, a little bit of bug hunting. Let's see if we can find where we went slightly wrong. So I've got 5mg minus, now let's have a look up here. Is it, your best going right the way up to the top really. F max is mu r. R was mg cos alpha. Cos alpha, hopefully I put down as 5/13. That's good. So that's going to be 12/13 mg. That looks nice to me. T minus 3mg sine alpha minus F max is good. Now that looks fine to me. It's probably going to be somewhere here in the rearrangement of this. Sine alpha was 12/13, and 3 times 12 is 36 mg/13. I like that. And this came to 12 mg/13. So we can definitely rewrite that as 48 mg/13. That looks good to me. So what are we getting now here? We've got, and then when I then basically made them both MA, didn't I? So I times that one by a 5th and I times this one by a 3rd. Have I just forgotten to times something by, that looks good. I tell you what I should have done here though, made that 16/39, 16, 32, 48, yeah. That would have made it slightly nicer to simplify. 16 over 39 plus... yeah, hang on a second. 16 over 13, I mean, like, you know, and then you haven't got the 39. Now, let me just do this bit again, because I did this quickly in my head, and it can easily go wrong there. 39 mg over 39 plus 48 mg over 39. 40 plus 40 is 98. Sorry, 88. Look, there we go. It's 87 here. That's what you get for not using a calculator. It's an easy mistake to make, to be honest. I'm an idiot. Okay, so, and that's a nice thing though. We know what the answer is here, and that's the kind of thing you have to do in the exam, isn't it? You know, some proper bug hunting. So that's going to make the answer fine, I think. 87 mg over 39. We're timesing it by 15 over 8, and I believe when we do that, once you've made that 5 and that 13, we're going to get 104 on the bottom, and 5 80s are 400 and 5 7s are 35, so we get 435 mg over 104, just as I said we would. Cool. And you want to show everything, but as you can see, the last 2 marks are really hard to get. But you've got 6 up there for doing all that. The initial equations are way more important than the working. I can't emphasize that enough. Now, after B reaches the ground, A continues to move up the plane. But when A is moving up the plane, this will be slack. Yeah, that's the key thing to realize, because it's tense. But the second B hits the ground, that rope goes slack and you've no longer got any tension. So what have you got? Now we've got to determine whether A will remain at rest. When it gets to the top, will it slip back down? Now, your friction is now going to be going up the plane. And basically, you've got to compare F max, the maximum friction available, to the weight. And the weight is pretty much still the same as it was before, because the weight is going to be, let's just remind myself what the weight was of this, 3 mg. And we're going to be comparing 3 mg sine alpha. So all you've got to do is point out, well, F max is mu r. And this hasn't changed at all, actually, because this will still be 4/5 times by r. But remember, r is 3 mg cos alpha. And that came to, we already worked it out before, it's exactly the same value as the one up here. It's 12 mg over 13. Yeah, so that's the maximum available friction, whereas the weight down the slope, well, that is going to be 3 mg sine alpha. And 3 mg sine alpha, well, sine alpha was 12/13, so that's going to be 36 mg over 13. And as the weight is greater than the friction, yes, it will move down the slope. I always do like to draw a second diagram out for that, though. It makes things a lot more obvious what's going on. It really does. It's really important to, check that it's definitely moving down the slope. Okay, I hope that was not too bad. I hope that was okay. But yeah, we just got to compare it to the weight, 3 mg sine alpha. So yeah, cool. Yeah, 3 mg. I just wanted to check sine alpha was definitely 12/13. So I think they got that wrong in the mark scheme looking at that. Unless I'm going crazy, it looks like they got it wrong in the mark scheme. They did make a mistake earlier in the mark scheme, I noticed as well. It's like, oh, they messed it up. Anyway, so just 2 refinements to the model that would make it more realistic. Well, there's lots of refinements you could make here. You've got the obvious one. Consider air resistance. Consider air resistance. That's often quite an easy one to get. Yeah. You could also use an extensible string. You could consider friction on the pulley. And you could consider, did they ignore the weight of the string? Yeah, you could consider the weight of the string. So there's quite a few answers you've got there. I'm giving you 4. But yeah, there's lots of ways of getting that final answer. Even if you've got, even if you've really struggled with a question, try and get those easy marks for modelling. Yeah, try and get them, because they're not too bad. They really aren't. Okay, anyway, I'm going to finish that there. I hope it was useful, and please do come and ask me or your maths teacher if you're still stuck on any of these questions. Keep up the great work. Okay, bye-bye.